In February 2026, Taiwan's vice premier said it was impossible to move nearly half of the island's chip-making capacity to the US, brushing off billions in American incentives. To most people, that sounds like politics, but it quietly sets off ripple effects that can nudge up the price of your next phone or even a car repair long before any factory doors close. Why does one country's refusal matter so much? And what hidden costs are now in play? On February 8, 2026, Taiwan's Vice Premier Cheng Li-chiun sat in front of the CTS cameras and delivered a message that echoed far beyond Taipei. She said moving 40% of Taiwan's semiconductor production to the United States was, in her words, impossible. The quote was quickly picked up by Reuters and other international outlets. Cheng explained her reasoning not with politics or posturing, but with a simple fact. The industry's foundation in Taiwan is too deep, too interconnected, to uproot at anyone's request. She described the chip ecosystem as an iceberg. What is visible on the surface is only a fraction of its true scale, with most of the critical connections, suppliers, and expertise built up over decades, hidden from view. This statement came in direct response to United States Commerce Secretary Howard Lutnick's push for the United States to claim 40% of the world's most advanced chip-making capacity, citing the risk of having 80% concentrated so close to China. The numbers behind Cheng's refusal are striking. Taiwan produces 60% of the world's semiconductors and holds a staggering 90% share of the most advanced chips. Yet, as Cheng emphasized, expansion abroad, like TSMC's massive investment in Arizona, does not mean uprooting what is at home. By making her position public, Cheng set the terms for what comes next. The world's most important supply chain would not be picked up and moved, no matter how strong the incentives or how urgent the requests from Washington. The TSMC Arizona project stands as one of the largest industrial undertakings ever attempted on U.S. soil. The reported $165 billion investment covers not just the construction of new fabrication plants, but also the sprawling web of suppliers, support facilities, and training programs needed to get advanced chip-making off the ground. The U.S. government has backed this effort with a $6.6 billion award under the CHIPS Act, a mix of grants and loans tied directly to hitting construction and production milestones. Yet even at this scale, the Arizona expansion is not a wholesale relocation of Taiwan's core operations. It is an outpost, ambitious, but still a fraction of TSMC's total capacity. A TSMC representative in Arizona describes the project as a build-out, not a shift. The goal is to add resilience to the global supply chain, not to uproot the foundation that took decades to establish back in Taiwan. Timelines reveal the challenge. The first Arizona fabrication plant is operational, but subsequent phases stretch years into the future, with advanced 3-nanometer production targeted for 2027 at the earliest. Meanwhile, Taiwan's domestic capacity continues to grow in parallel, reinforcing the idea that expansion abroad is meant to complement, not replace, the island's central role. A map of the supply chain tells the story plainly. Taiwan remains the dense manufacturing hub. Arizona, the new outpost, and the shipping lanes between them form the arteries that keep chips flowing to U.S. ports. The distinction between expansion and relocation is not just technical. It is the dividing line between what is possible and what is not, no matter how much money or incentive is on the table. Capacity in the chip world is not a pile of finished products waiting on a shelf. It is the ability to turn out working, high-yield chips on a regular schedule using the latest process technology. That means more than a big building. It means a factory called a fab, which is short for fabrication plant. Inside a fab, the air is filtered so tightly that a single dust particle can ruin millions of dollars in wafers. The entire process depends on extreme precision and a web of suppliers who know exactly how to keep things running. A former fab engineer once compared the environment to an operating room. One mistake, and the whole batch is lost. The most advanced chips rely on a tool called an extreme ultraviolet lithography machine. These machines can etch features so small they are measured in billionths of a meter. But here is the catch. Only one company makes extreme ultraviolet machines, ASML in the Netherlands. Fewer than 200 of these tools exist worldwide, and installing just one takes months of calibration by teams who have spent years mastering the process. Yield is another word you will hear. It means the percentage of chips that actually work at the end of production. In Taiwan's mature fabs, yields can reach 90% or higher. In a new site, even with the same machines, yields start lower and take years to climb. That gap in yield is why capacity cannot be copied overnight. It is not just about hardware. It is about experience, teamwork, and a supply chain that learns together, mistake by mistake, over decades. Concentration has always been the semiconductor industry's double-edged sword. Most of the world's advanced chips come from a handful of factories in Taiwan, and that clustering brings both efficiency and risk. When so much production sits in one place, any disruption, political, natural, or logistical, turns into a global problem. As one economist puts it, this is a classic tax uncertainty. Companies pay extra, not for more chips, but for the peace of mind that they won't run out. That cost shows up in the choices made far from the clean room. Tech firms sign expensive contracts for guaranteed supply, automakers stockpile chips, and electronics brands line up alternate suppliers just in case. Even if no physical shortage hits, the mere possibility of trouble leads to higher prices. This is not about panic buying. It is about building in buffers, redundancies, and insurance, costs that ripple through the supply chain and land in the final price of a phone, a laptop, or a car repair. The more concentrated the choke point, the higher this risk premium climbs, no matter how steady the actual flow of chips remains. Tariffs on semiconductors do not land on a foreign company's doorstep. They arrive as a bill for the importer, right at the US border. When a shipment of advanced chips enters the country, the importer pays a duty, recently set at 25% for certain categories, directly to Customs and Border Protection. That charge is immediate and non-negotiable. The foreign chipmaker is not the one wiring funds to Washington. It is the US company bringing those chips in, whether they are destined for a phone factory in Texas or an auto supplier in Michigan. Once that tariff is paid, the cost begins to ripple. Importers might try to negotiate partial rebates from their overseas suppliers or swallow a slice of the charge in their own margins. But most of the time, the extra cost gets woven into contracts and pricing agreements. The more competitive the market, the faster it moves downstream. By the time a mid-range smartphone or a replacement car part reaches the checkout counter, the tariff has become part of the sticker price or the deal you used to get. Picture a receipt. It does not say tariff, but the cost of that chip-heavy component has nudged upward, quietly shifting the bottom line for buyers and sellers alike. Chip price shifts rarely appear overnight. Contracts in the auto and electronics industries often fix prices well in advance, so when tariffs or supply shocks hit, companies lean on existing inventories before making changes. That lag between a new policy and its real impact can stretch from a few months for consumer tech to over a year for vehicle parts, especially with lengthy procurement and testing cycles. As one OEM procurement manager puts it, by the time a tariff affects their chips, they are still assembling cars with last season's stock, and the true cost emerges with the next round of orders. Two scenarios tend to unfold. If policy friction rises through higher tariffs or stricter sourcing, uncertainty grows, especially for mid-tier electronics and auto parts. Companies may rush to reshore production, but higher costs and slower yields keep prices elevated. If instead governments manage a gradual transition with clear rules and steady capacity growth, firms can plan and price spikes are less severe, though supply and demand still pull at the numbers. 3 indicators offer early clues: milestone delays at major US chip fabs, the pace and conditions of CHIPS Act funding, and rising import price indexes for electronics and vehicle parts. Each signal hints at what is coming, with price changes trailing supply shocks by months. Right now, every phone, car, and appliance price reflects a bet on stability halfway around the world. As policymakers push and factories resist, uncertainty itself gets priced in long before shortages appear. In this supply chain, the cost of doubt is real, and it lands in your cart.